All right, so in this video, we're going to go over an example problem involving Newton's law of cooling. So here we have that Y represents the temperature in degrees Fahrenheit of an object in a room whose temperature is kept at a constant 60 degrees. The object cools from 100 degrees to 90 degrees in 10 minutes. We have to figure out how much longer it will take for the temperature of the object to decrease to 80 degrees. Okay, so Newton's law of cooling says that the rate of change of the temperature of an object, so let Y represent the temperature of the object, so dy dt is equal to K times the difference in the temperature of the object and its surroundings. So K times Y minus T. Well, T sub S will be the temperature of the surroundings. So this K represents the constant of proportionality. So it's basically saying the rate of change of the temperature of an object is proportional to the difference of the temperature of the object and its surroundings. And that makes sense because if an object is, in a colder room, it's going to cool down. Like if you're after you boil like a cup of coffee, the temperature of the room is going to be obviously is going to be lower than it. So that's why the teapot or the coffee pot will cool down. So we have to figure out essentially the equation for y of t, and in that we'll find our value of k. Then we can figure out how long it's going to take for the temperature to decrease to 80 degrees. Okay, so we're essentially going to integrate. And what we want to do first is bring all the y terms to the left and the large T and the other terms to the right. So let's look at this. So what we're going to do is we're going to divide by this quantity y minus T sub S. But first, let's actually, well, first we definitely should. We're given that the temperature of the room is constant at 60 degrees, so T sub S is 60. So we can rewrite our equation as dy dt equals K times y minus 60. So what we're going to do is we're going to multiply the right side by dt and divide the left side by y minus 60. So this will lead us to dy divided by y minus 60 being equal to k times dt, or k dt. And then from here, we're going to integrate. So we're going to set up an integral on each side. Integrating is going to allow us to find an equation for y. So we integrate the left side. That will be the natural log of the absolute value of y minus 60. The right side is simply just k times t, kt. Because k, remember, is a constant, it's not a variable. And then from here, we're going to use the exponential property. Remember that this represents the logarithm with base e. There's technically an e here. So we can rewrite this as e to the kt is equal to y minus 60. And I almost forgot my constant. So let's put that plus c. Oops. So I'm going to write y equals y to the kt plus c will equal y minus 60. So it'll be like this. We'll get y minus 60 is equal to e to the kt plus c. Remember this raised to that, this whole group is equal to this. And I'm taking away the absolute value symbols because we know that y minus 60 is going to be a positive number because the object is cooling. The object is going to be greater than 60, so y minus 60 is going to be positive. So now we essentially just have to solve for y. So we can rewrite this as y minus 60 is equal to e to the kt times e to the c, because just by the power property of exponents, because if you add the same base, you can add those exponents. And what we're going to do is we're going to make e to the c equal to a. If we make e to the c equal to a, make this equal to a, then a is essentially just like the coefficient of this. It's just a times e to the kt. And that's because, remember, e to the c is just a number. It's not going to be like a variable, because e is about a number with like 2.71ish, and c is going to be some other constant. We don't know what the constant is, but it's still a constant nonetheless. And now we just have to add 60 to both sides, and we'll get y is equal to a e to the kt plus 60. Now we have to solve now for a, and a is just our initial value, and we can find that out or show that's the initial value by just evaluating this at t equals 0. Because when t equals 0, we're told that the object goes from 100 degrees to 90. So that means y of 0, or y is just 100 when t is 0. So that we can write this as 100 being equal to this whole thing. 100 equals a e to the kt plus 60. Whoops, and then this t is just a 0. So it's really a times e to the 0 plus 60. E to the 0 is just a 1. So all you have here is 100 is equal to a times 1 plus 60. And then a is going to be 40. Then your equation for y is just going to be 40e to the kt plus 60. Okay, that's our equation for y. Now we just find our value of k, our constant of proportionality, if I can pronounce it correctly. And we can figure that out by the other piece of information we're given. We're given that it cools from 100 degrees to 90 degrees in 10 minutes. So it's saying essentially when t is 10, y is 90, because y of 10 is 90. So we can set 90 equal to 40e to the k times 10, but I'll just write it as 10k plus 60. I'm going to solve for this. I'm going to subtract 60 from both sides. So I'll get 30 equals 40e to the 10k. Divide by 40, and I'll get 3/4 equals e to the 10k. And then take the logarithm of both sides. I'm going to take the logarithm, or the natural logarithm, of 3/4, and that'll be equal to the natural log of e to the 10k And just by the property of logarithms, these are both, this has the same base as e, so then the right side will just be equal to 10k. So the natural log of 3/4 is simply equal to 10k. And I can solve for k by dividing this by 10. And I'm gonna use a calculator for that. Natural log of 0.75 divided by 10 be this decimal. Negative 0.028768207.2. Okay, so now I can write my function, and let me just write as y of t officially as 40e, replace the k with this, 40e to the negative 0.028768207.2 plus 60. All right, now that I have my equation for y, I can figure out how long it's going to take to cool down to 80 degrees by just setting this equation equal to 80 and solving for t. So making this equal to 80. I'm going to take away 60, 20, then 20 divided by 40, I'll get 1/2. 20 divided by 40, 1/2 will be equal to e to the negative 0.028768207.2t. And then now I can just take the natural log of both sides again. The natural log of 1/2 will be equal to the natural log of this, or it'll just be equal to this, because if I take the natural log again of e, that'll just be that. So the natural log of that will be equal to negative 0.028768207.2t. And then I just divide both sides by this. So let me just do it in my calculator. Natural log of 0.5 divided by negative 0.028768207.2. Bang. We're gonna get it's about 24.09 minutes. All right, so there you go. I hope that helps. Good luck.